Hi everyone, welcome back. I guess technically this would be episode 31. Yeah, I'm not really gonna number my episodes anymore because it seems like when I do that, everyone just goes and watches episode 1 and thinks that they have to watch them all in order, so... Yeah, let's plot a few functions. There's e to the x, and there's x squared, and x cubed, and let's see, we got ln x in there. Oh yeah, 1 over x, and then ln x. And okay, finally, that took long enough. Yeah, this calculator's been going a little slow lately. I wonder if there's anything. Oh yeah, I wanted to show you guys. I got the new TI-84 Plus CE. Comes with color, more memory, and a faster processor. So let's go ahead and look at the stats at the bottom here. As you can see, the screen is bigger. It's 320 by 240 instead of 96 by 64. Let's actually compare how many more pixels that is. So 96 times 64 is how many our current calculator has, right? So 6,144. That's actually a lot of pixels. But 320 by 240. Look at that number. Let's divide it. That's 12 times as many pixels. 12 and a half. It's more than 12 times as many pixels. So yeah. I'm not sure the ROM and the RAM comparison exactly. What their megabyte or kilobyte means. Because in base 2, the number of kilobytes in a megabyte, I believe... Actually, you know what? I think... I'm not sure, but the number of kilobytes, regardless of whether you're using the base 10 kilobyte or the binary kilobyte, should still be the same, have this go into the megabytes the same number of times, because I think the megabytes, even if you're doing it in base 2, it's still approximating as close as possible to 1 million bytes. So anyway, let's just assume that the number of megabytes that they have listed here is in fact 1,000 of the number of kilobytes that they have listed here. And we'll do the math on that. So we're going to say 3,000 divided by 480. Okay, so it looks like the ROM would be increased by 6 1/4 if their megabytes is in fact 1,000 times larger than their kilobytes, which I should have checked that actually. But I'm not sure if I can give you guys a positive knowledge of whether their kilobytes and megabytes in general are base 10 or base 2. But I should note, you know, if they're base 2, whether it's 1,000. And it looks like the amount of RAM that's increased is by 77/12. So what is the fractional part, no, the int of that? The int of 77/12, 6. So the RAM is about 6 times as much too, which is nice because usually we run out of space with the matrices, and now it'll be a lot easier to deal with that stuff. And as you can see, we've gained the color and backlit display. We've gained the rechargeable battery, and we've gained the ability to import images. And as you can also see, the TI-89 can do something that we can't do, which is computer algebra system. I actually used to code with the TI-89. The reason why I don't use it, or the reason why I don't like it, well, first of all, I don't have the TI-89 anymore, but even though it was pretty powerful for its time and everything, it wasn't like everyone had one, so it was kind of interesting to know how to do a TI-84 because it seemed like everyone had one, and because I liked how the blocks were bigger and more clear cut. It just was interesting to me for the programs that I was trying to make. I liked doing programs for some reason. It was really my favorite thing to do programs using just characters instead of pixels, and it also worked fast on this calculator. So yep, TI-84 was kind of the thing that I did. Now we got a new one, and it's faster and better, and we're going to compare them, and we're actually going to compare how quickly they do some things. So alright, test 1. We're going to compare the graphing speed of both calculators. There we go. Let's see how long it takes. There's e to the x. There's x squared. Oh, what? It looks like the new one is trying to graph so many pixels that it actually takes longer. It looks nicer, mind you, but it is taking longer. So there should be a setting that gets me the general look of those graphs quicker. Otherwise, when I take my math test or when I try to look up a function, I would prefer the old one. So if you make a new calculator, you want it to be strictly better. So I'm not sure. We might be able to change the settings on the zoom or something, but when you just go straight into the plot, looks like looks like it'll still take longer. So I think since we did the exact same thing for both calculators as far as input and as far as what, you know, a normal user would do, we should leave the test at that. But we can obviously go in and see if we can change the settings later. But since we did want to just test what would happen if we just plotted functions, which we'll probably need to do every once in a while, we're going to say our old TI-84 Plus won that round. Alright, so I wrote a program on each of these calculators that go from 1 to 16 and 1 to 8 and loop through and kind of give us random zeros and ones. But I haven't run these programs yet, and I'm pretty sure that the entire screen here on the new TI-84 Plus CE will not be filled up. So first we're going to run it just to see kind of how much more space we have character-wise. So let's go ahead and run program A here. Ooh, I see. So I noticed that it's not only printing the zeros and ones, but it's actually printing wherever I tell it to. It's also printing a bracketed number, which I hope I can kind of turn that setting off. It didn't look like it went necessarily that fast either. Well, let's run that one more time and pay attention to how quickly it does it. Ready, set. Oh, let's clear the screen first. Here we go. Ready? Go. Wow. Looks like our old TI-84 Plus was actually faster. This new calculator is starting to disappoint me. I don't even know if the for loops go as fast anymore. I don't know what's wrong. What are they doing with this thing? Did they kind of make it more high level? And I don't know. This isn't looking too good. Let's see how many characters more it went. Well, the done is about 4 characters, and it looks like there's somewhere in 4 or 5 characters between the done and where these ones and zeros are. So we might, let's see. So if we add 9, we have 25 across, and then vertically we'd have 10, I guess. So let's go ahead and try doing that. Let's try 25 and 10 and running that. Yep, I think I got the height correct. And it looks like I got the width correct too. So it looks like we got 25 by 10. I like that. They're kind of clean numbers in the base 10 system. But they're no longer base 2 numbers, so not too worried about that. I'm kind of more worried about the speed. I really want it to go fast. I don't know, it's kind of disappointing. I'm not sure if I was kind of excited to make, you know, a new program. It was going to be Tetris. That was supposed to be kind of a surprise, but now I'm not sure how well that's going to go anymore, because I can't really make games with this because the brackets. It's kind of disappointing. Anyway, let's move on to our next test. Okay, we're here on a for loop that displays numbers, and we're going to see which calculator wins the race. So let's go ahead, we're going to go into A, and then run both of them at the same time. Ready, set, go. And the old one is getting ahead. Uh-oh. That's very disappointing. So this new calculator is supposed to be faster, it's supposed to be better, and it looks like whatever they've done, they have not tested or compared the TI basic part of it, and that's really disappointing. In fact, after this test here, I'm actually considering whether I want to return this calculator or not. But here we're just testing the display output. So it looks like the TI-84 Plus is a lot faster at displaying on the screen. So it's probably doing less overhead. The new one's probably doing a lot of processing associated with managing the screen scrolling or something. I'm not sure if you can scroll up, but it's definitely taking a lot longer to get to 1,000 here on the new one, which is very disappointing. Man, this is a killer. This is a killer episode. I was so excited. Wow. Maybe we're gonna stick with the TI-84 Plus Silver. I think we're gonna have to stick with the old one. This new one has disappointed us in almost every way. Let's run another test. Okay, here we are. We have another test. We're going to compare the for loop speed this time instead of the display speed. So I just moved the display A outside of the for loop. So we're going to see how fast it can just loop internally without messing with the screen. And both of them are going to go to 1,000. And we're going to see which one gets there first. Ooh, the new one's faster. Nice. Okay, so it was kind of what I suspected, the screen. Finally, man, the TI-84 Plus CE finally beat the old calculator in something. Seemed like that it did that pretty quick. So far the only issues I see with the calculator that are concerning are related to the screen, and I'm not sure if I can change settings for that or get more of a low-level access to the screen. But yeah, if we could just fix that problem, I think I would be pleased with the calculator. But that's, for me right now, that's a big issue. And there was another test that I was planning on doing, and I'm really hoping that the new calculator will do a lot better on this new test that I'm about to show you. And because this new test involves using a little bit of memory. Alright, so we got a matrix test here. We set a 10 by 10 matrix, and then we loop through it and we put in the sum of our indices, and then we display it. And now the thing that I'm worried about is I'm wondering if the new calculator will crash here because I didn't end the parentheses. But we're going to test that. I don't think it should. I think if they force you to end the parentheses, that they made a mistake with that design plan, because it's non-ambiguous, so it's not like you need to end the parentheses for any reason. Because I'm not going to be able to do a store within a bracket anyway, unless I could, of course, but I'm pretty sure they didn't change it that much. So this one should work. If it doesn't, I'm going to be a little bit disappointed, but I also will be disappointed if it is slower if it does work. So let's run that. Okay, it looks like it worked. Oh, what? Really? Wow. You know what? It might have been the display, but let's run it again. It looked like they hit there about the same time. Now I want to go through here and I want to change this. So instead of displaying A here at the end, we're actually going to display just the number 1. Okay, that way we're not comparing how fast they can print the matrices, we're just comparing how fast they can set the values in the matrices. So let's run that. Okay, it looks like the new one wins. Let's do it again. Ready? 1, 2, 3. Yep. Looks like the new one is faster at filling the matrix. In fact, I'm going to show you how much faster by doing a while loop here. Oops. Okay, so what I'm going to do is I'm going to, oops, wow, apparently I don't know how to use the new calculator. Okay, so while 1, and we're going to display B, and then I didn't want to go there. Okay. So B plus 1 stars B, and 0 stars B. Okay, we're going to do the same thing here. 0 stars B, while 1, B plus 1 stars B, and then end after we display B. Okay, so now we're going to see which one's actually faster at filling the matrices and how much faster. And I don't know why it's printing 11. That's a weird... They're both doing it too, which is... Oh, I know why. I'm using the wrong... a bad variable to use there. This should be a different variable, not B, so we're going to change it to C. I don't know what I was thinking. B was not a... Would you call it a free variable? So... let's change it to C. And run. So here we go. 4, 5, 6. So it's just a little bit faster. It's not really actually going that much faster. I was hoping, you know, it'd be a lot faster, but, you know, I guess things work out differently than what you expect. So at least internally it's faster, which is kind of what I was more sure about expecting, but I did not actually expect the screen to kind of catch me off guard there and being slower, and it's just really disappointing that that's the case. So here we go, we already got to 50. So 5/4 faster, it seems to be about 25% faster, that's about it. Oh man. So is it going to make it to 100 while our old one is at 80? Probably. It's the looks of it. Looks like our old one won't even make it to 80 actually. Might just be around 75 or so. 76 and 78. It didn't even make it to 80. Okay, so the new one is a bit faster when it comes to setting matrices, but it's not that impressive. I'm not sure if this was worth the money for the upgrade. It is cool that we can draw in colors and we have a bigger screen. That is pretty cool. I will admit that. But the screen is also proving to be a little bit of a problem. I hate to be such a downer, but that's what we get. Okay, I'm gonna stop this here. Okay, here we are. We're seeing if the new one at least is faster at drawing text on the draw screen. So let's mess with that. We're doing the exact number of characters the same. So here we have a loop. It pretty much just goes through the loop, finds the modular of 10 of the sum of the coordinates, and it draws that to the screen. So we run this, and the new one is actually finishing that faster, which is interesting. So it's almost like we should be using the draw screen when we do stuff. Although the screen is kind of not, there's like a margin here, so it's like, why make a game where there's like a big margin? I don't know. I guess we could turn on the axis off and maybe do something about the margin. We'll see. Not too sure about it yet. I guess this might not be the only episode of this. I did add another thing at the bottom here so we can clearly see when one of them is done and how fast it transitions. So let's just run it with that line. Okay, there we go. So the new one is faster at drawing text on the screen. Interestingly, I do want to see how much faster it is at drawing pixels, because it seems like it wants to fight, it wants to catch up and be like, no, you've been testing me in the wrong spot. Don't test my text output ability. Test my plot output. So we're testing the draw screen from now on. But let's do that. Okay, we're gonna compare the same number of pixels, and the way we're doing that is with this program right here. So I'm using pixel change. So it has to access the pixel memory to see what it is, and then swap it and store that back into the memory. So let's run that. And it's like a race. Which bar is faster? And the new one is faster at plotting that same number of pixels. So it looks like the draw screen is quicker per pixel. But the problem is we want it per screen size because we want our game to be a full screen game. So we want to control the pixels to let us like play Tetris or something, and if we need to turn on like 50 pixels for a single block instead of just 10, that's gonna take longer actually, because I'm sure that these were similar in speed. So if I try to fill up the new one's screen all the way, it would definitely take longer, which is a problem. Um, so more pixels does not necessarily mean a better calculator, because now the screen is actually, to get the same effect, you might have to look at a very small section of a screen. I don't want to make a Tetris game that just plays up here in the corner of the calculator. I want it to be full screen. And there's no way to group the pixels apparently. We can't output the text faster in the normal screen right here in the display screen. Which is the easiest way to group pixels. I mean, they group them by characters, and if we can't do that, and use like O's, for example, for our Tetris blocks, which I usually do, then there's a problem, and we'd have to write something in assembly, which is a lot more difficult, a lot more time consuming, and a lot less fun for a lot more people. Because a lot less people will have the ability to, and the time to actually do something like that. I'm pretty sure not all my subscribers actually want to program Tetris in assembly. They might want to do it in TI Basic, but not necessarily assembly code. So this is still a little. I've been kind of cheating on behalf of the new calculator too, by giving it smaller areas and comparing it per pixels instead of per screen size. I was hoping to do the whole screen size comparison and be more demanding and be more brutal with the tests, but it seems like it can't handle the inputs and outputs very well, and that's kind of sad for me, because one of the things that they boast about the most on this calculator is the screen, you know, the color of it, the pixels, all that. I mean, it's like the favorite thing that they advertise about this calculator is the screen. So if the screen is supposed to be so great, why isn't it fast? Why can't I access it more quickly? You shouldn't add pixels unless it's strictly as fast as the old calculator or faster, to get for in every way, in every sense, like for per screen size, per the area that you're actually looking at, not per pixel, but even per area, and per character it is actually slower. And I don't like how it outputs with brackets. I really don't understand why they changed that. I have a big problem with that. That's not good. I want to put coordinates here like 5, 5, you know, and I might be able to do it from the home area. So if I do it from here, I can do like 5, 5, and then I should. Well, let's see what happens if I put a theta. Attempted to use a variable or function where it is not valid. Really? So I'm not allowed to use the output command. Am I not allowed to use the output command for this calculator either? I thought I could. Oh, I guess not. Wow. Okay. Guess I wasn't paying attention there. Well, we're done with this pixel test. If anybody knows how to do the outputting, I guess I won't return the calculator right away, but I do. I'm talking about returning the calculator already. Because I want to hear what you guys have to say about it, or someone. Wait a minute. What? It didn't do the brackets. What's up with that? I thought it was doing the brackets. What? Wait, okay. I am very confused right now. For A is 1 to 10. For B is 1 to 25. Output B, A. And then if I just put 6, sorry, AB. Oh, wow. What? Huh. So, wait a minute. So I can't do an expression. Okay, I'm really confused. When I did output before, you guys all saw it. Wait, is it more than 25? Is it 26? Am I like delusional here? It's 26. I'm so confused right now. What happened? It was... What? What? It can do it? I'm so... What just happened? Okay, I have to like I have to check my old videos because it was outputting the brackets before, remember? The brackets. The brackets. Let's try 6 plus 1. What? It's not doing it. And it's fast. Oh my goodness. Oh my goodness. Well, hold on. Hold on. Let me... Okay, I have to check the video. I'll be right back. Okay. Okay, we're starting that the for loop test. We're starting that over. This is a good thing. I totally did not realize I made a mistake, and I'm so glad that I made this. That this was my mistake instead of the calculator actually being slower. So check this out. Okay, so in the old calculator, when you do random int, like 0, 1, it'll give you a random integer, and it's just one integer, right? So in the new one, I assumed that I was going to get the same thing. It gave me a lower and upper, so I just kind of thought, oh, okay, lower, upper, n equals 1. You know, I thought n, what did I even think n was? I guess I didn't even think about it. I'm not even sure what I thought n was, but I guess n is the number of ints that you're getting. So if n is 1, you get 1. If n is 2, you get 2. And actually, I haven't even tried 2 yet, but I know what's going on. It's a set. It's like a list. It's giving me a list, which I don't like as far as no repeat. Okay, I don't really like that they removed the option. But you know what? It's not that big of a deal, I guess, because usually you want you know, it might be the displaying of the int. Here, you know what? Forget that. It might be just as fast anyway if we do it internally. So you know what? I'm not going to be too concerned about it at this moment. But first things first, I want to test the actual filling up of the screen. So that's what we're going to do. We're going to do that. And we're going to see which one is faster. So for A is 1 to 16. That would be 8. For B is 1 to 16. We're going to output A, comma B, and then we're going to put just a 0. So there's no confusion in what's going on. We're not doing random ints and all that stuff. Okay, now. Well, I want to make sure the programs are pretty much the same here. So now, this one will print more characters, but we want to compare how fast it takes to fill the screen. So let's do this. Ready, set, go. It does take longer still. It does take longer. Let's run it again. Yeah, it does take longer still. So let's cheat a little bit for the new one to give it some slack. And let's make sure to actually at least print the characters as fast. It's taking longer to run the program. You notice that? Like, I have to press enter at the same time, but this one takes longer before it loads it. So let's press enter on the new one first, and then compare how fast the filling takes. So enter, enter. They're about the same. Enter, enter. Yeah, the speed at which they fill is about the same. When I press enter at the same time, ready, set, enter. Like, see that? This one, like, pauses because it's trying to, like, load the program. I don't know why it does that. That's weird. But it is kind of... At least it's, like, as fast now. At least per character. But it's not as fast at filling the screen. That... I was excited because I thought my mistake was gonna give us some slack here. We can program... I guess we can program Tetris in color. Okay, the TI-84, because it's internally quicker, it might have actually proven itself, because that's... Once I make a complicated enough program, that's actually the part that usually matters. It's the internal processing. So even if we do Conway's Game of Life, like, it'll take a while for it to update the screen for that, like, each pixel, right? But the internal stuff will probably be way faster. Which is a good thing. That's Okay, I guess the screen is at least as fast. It's not really that much faster, though. Not really that impressive, I guess. But I'm glad that I can output at least. I was really mad that those sets were being printed, but I realized that they were lists. I realized what I was doing wrong, so I'm leaning on not necessarily returning the calculator anymore, and probably considering it possibly better in a lot of situations, but it's not as convincing as I would like it to be. So there you go. TI-84 plus CE. Put it through the fire. Burned the I should have had the text in view there. I burned the calculator a lot with my tests, and it held up in a few places pretty decently. Not as much as I wanted it to, but it I think it will make for some interesting programming. I don't think I'm going to get rid of my TI-84 Plus Silver Edition yet, though, because it proves that it still has some nice things about it that are better, that make it better than the new one. Loading programs, its response time, things like that. I really like that. Tell me what you guys think, comment, whatever, and tell me what you think about me not numbering my episodes anymore, because I kind of want to make them more searchable based on their titles rather than their episode number. Anyway, this has been Calculator Programming with Tim. We will program Tetris next time. I will see you later.